second video of our OpenFPGA tutorial series. So in previous video, I have shown you that how you will install the dependencies for the OpenFPGA. So without wasting any time, let's start our first design. Okay, so I have this OpenFPGA installed at this location. What you have to do for the first step, you have to basically source this openfpga.sh, which is a shell script. So what this file does, it actually sets the openfpga path variable for you. So we'll simply open in terminal and we will source this file sh. So it will check if we already have this OpenFPGA variable or not. In case if it is not available, then it will set the path, which is the current directory. This directory will be acting as a root for our design next for our subsequent projects that we wish to compile. Okay, so let's. So once this OpenFPGA variable is set, we can simply type a command disk minus tasks. So it will show you a list of tasks that you can do in OpenFPGA, such as you can see VTR, Verilog to routing, and then regression tests, benchmarks. So these are tasks. This is a list of the tasks that we can perform in our designs. It's an extensive list you can go through in your own time. And so they also have they have this template of tasks. So we will be using this VTR benchmarks template. So I will show you in a while that what type of benchmarks and architecture files that they have placed here in that directory. Okay, so once mm, you have this task list, and then we will simply uh, create a task and simply run it. Uh, so I am making a new directory, which I call it my task. So we will navigate to this directory and then we will create a task. So the command that is used in order to create an OpenFPG task is create dash task, and you will supply a name. Let's say it is our task number 1. And then we will specify these one of these 4 names. So basically they have provided templates. So for the same simpler design, we're using this VTR underscore benchmarks. So you will simply type this VTR underscore benchmarks, enter, and it has created a task for us with the template project VTR benchmarks using this VTR underscore benchmarks underscore template. Okay. So let's navigate this directory and see what type of files we have in this folder. So here is our directory which I created, and we have this task number 1 directory. Okay, so in this template that is generated by the OpenFPGA command, or you can say the create task command. So we are provided with 2 architecture files, and then there is an OpenFPGA script. So if we just open this file and see, so it executes a sequence of commands which mm, you will run in your projects. So first of all, this is just a very basic simple command. We are just invoking the VPR standalone tool. So VPR takes actually 2 arguments. The one is the architecture file, and the second argument is the VPR lib file. And then you specify the routing channel width and what type of route method that you wish to specify uh, in your designs. Okay. Then they also provide this uh, configuration file. So we'll see in a while, and they have given us two architecture files having different properties. So let's, for the sake of just to go through an overview of this XML file, you will be covering this XML file in detail in the later uh, videos. So in our XML file, the architecture file, we have these tags, which the first tag is actually the models. So that the models that are defined in the netlist, so they'll be mapped on this. Like, so we have this IO model name, and we have the structure table, lookup table, which has 6 inputs. Not going in the details of this. And then we have this RAM model. So it will infer a 1 kilobyte memory, each location having 8 data bits. And then we have this multiplier model, which will be acting as a DSP slice for our design. So we will cover this later in future. Okay, so the configuration file, if we go through it, so it has a set of, you can say, basically specify some of the properties. Like in general, if you want to do power analysis, then you will set this flag to false. So you want to generate a spice output, so you can set it to true. Similarly, if you want to generate the netlist in the form of Verilog, then you set as true, and then time for each job or each task is uh, supply. And then we want to specify which type of FPGA flows we want to use it. So we are currently using uses underscore VPR and technology file, and that on which nanometer technology node the architecture is going to be mapped on. So by default, it has picked up the 45 nanometer, and the information of the or all the physical properties, the specifications are provided in this 45 nanometer .xml file. So in order to invoke open FPGA shell, we are basically supplying this parameter. So the open FPGA shell template, which I just show you previously. So it's a script that runs a sequence of commands in the open FPGA task. Then we specify the open FPGA architecture file. So the open FPGA architecture file is basically where the physical properties of memory or the DSP blocks, or even the lookup tables are defined. And we also specify the configuration or the bitstream loading method that you want to program in FPGA or a fabric. Then we have the simulation settings parameter. You want either fixed simulation settings or a different simulation setting. We will look in detail in some of the future videos as well. And then we supply the routing channel width. So by default, it is 300. So in the default template that is generated by this create minus task command, so we have just two architecture files that are in the task directory, which is K6 and 10 valuable with 8 kilo uh, byte memory, and we have this DSP slice, and there is it, and it will be mapped on the 40 nanometer technology node. The second architecture files has a dedicated carry chain address, so it's slightly different with the previous architecture, and then we specify the benchmarks that we want to run, and then there is synthesis parameter option. So it has a large number of parameters you can specify in your design. So we will look. We're looking just going. We'll be having an overview and will not go to too much details. You can read out the documentation uh, as well. Then we have this the benchmarks top modules. So we have four designs. So each design has a top module. So we specified it, and then these are the parameters that we will be using in future, like when you want to do some compilation verification or the formal verification. So you can uncomment it, but right now it is we are not using it, so we will just simply leave it as it is. Okay, so when you run this task, you will simply write this command run minus task, and then you will specify the task uh, name, which is in our case task one. So OpenFPGA will run. It will. This line is important. So just to show you that it found two architectures and four benchmarks and one script parameter. So it is creating 8 jobs currently. So we want to evaluate our design on two architectures. So we have four Verilog benchmark circuits and two architecture files. So we have this total 8 jobs in our design. So depending upon your design complexity or size, this will take a little while. Okay, so when your task execution is successful, you will get this message, task execution completed. In case you get an error, you will get a non-zero uh, done status. So let's navigate through this directory and see what type of files it has generated. So it will create a run folder every single time when you compile or run this task. So in run 001 directory, we have these two different architectures, the K6 and the factorable with tileable adder and the simple one with no carry chain adders. So and we have these four different designs. Uh, if you can navigate further in this directory, so it has created a set of different output files. So if we go back to the configuration file, the task configuration file, this OpenFPG script. So we are just running this VPR currently. So once you run VPR, it generates a set of files for us, and we can see the uh, set of files that are present here, and you can check out the log files and the OpenFPGA log file that gives information that which step has been run. So here it has done the synthesis part, and then after that it will do the routing part. So it has created a 20 by 20 grid. So we can look into that as well. So you can see the FPGA size is 20 by 20 and it has 400 grid tiles, which is auto-generated. We will look into these specifics with detail in the later sections. All right, so once it is done, so we can have a look at the generated FPGA architecture. So the VPR actually, if we go back, so this is the command that is basically run. So VPR takes two arguments. The one is the architecture file and one is the blib file. So we will supply this and let's see the layout of the design in our scenario. So in order to do that, you will simply go to this OpenFPGA directory, go to the build folder, then go to this directory VTR Verilog to routing, click VPR, and we will basically you invoke this executable file. So we will follow this command. So first we will supply this architecture file. And simply copy it and paste it here. And then second parameter is the blib file that you will provide. Right, so we have the blib file, and to read the command, we will supply these routing channel width parameter and the constant math method. Right, so once this step is done, we'll simply rerun it, but this time with a different parameter, and we will supply these parameters minus minus analysis. And you, if you want to view the look generated layout, you can simply write this command minus minus display and then on. All right, so you can see this is the layout that is generated for our design. So it has a you can see these are the sections that the blue denotes the logic that is mapped in the CLBs. And these small columns are basically showing you the block RAMs, and these yellow vertical columns are our DSP slices. We will look in detail in the later videos. If you click, so basically it also shows you the routing that is being done in the design. So you can experiment with your designs as well. So we will be covering this in detail. So do play around with your designs and give us your feedback and comments. I will be willing to help you in your designs. So that's it, and take care for the next video. See you in the next session. Goodbye.